Hi, welcome to another math lesson with Miss Dolor. So we're learning today is all about perfect squares and non-perfect squares. So we're going to write down here for note-taking purposes, right here, perfect squares. I'll try my best to have a nice handwriting today. So perfect squares. Still not good. Okay, perfect squares is letter A. Letter A. I don't like the word, so let's need to write that. So perfect squares. If you have a nicer handwriting, go ahead, do that. And non-perfect squares. So the meaning of the word non is not perfect squares. So non-perfect squares. Okay. So I would like to discuss first what's a perfect square. So as you remember, a square has four equal sides, right? So we're going to get one rubber band. Okay, here. Oops. So I need a square with one unit as each side. So if I'll find the area for this, that will be equal to what? 1 times 1 equals to what? 1. So 1 squared, because you multiplied 1 twice by itself. So 1 squared is equals to 1, right? Whenever you multiply 1 by itself, just 1. So therefore, the opposite of squaring a number is you do the square root of that. So square root of 1 is equals to just 1. Okay? For some reason, my pen is not working nice. I am very particular with handwriting, so I'm trying my best. Okay, next, I will get another rubber band here. We'll have 2 and 2. So, oops, it's not right. So you have here, I need you here, so I have 2 and 2. So you have this one and here, right? So here, your unit will be what? 2 sides each, right? This is 1 and 1. If you count the units, just 1. So here, the I'm gonna write down here like lines so that you're not gonna overlap. So I'll find the area for this pink square will be 2 times 2, right? Equals 4. 2 squared equals 4. So if you square root that, 4, square root of 4 is equals to 2. Okay, you see now the pattern here? Okay, square root is a number which produces specified quantity when multiplied by a number. So 2 is the specified number that when you multiply it by itself, you will get 4. So that's the meaning of the word square root. Okay, next we have by 3, right? So I'll get the yellow, I get the yellow rubber band, so I will have 3, right? And I have another 3 here, 1, 2, 3, 1, 2, 3. So this will become what? 3 and 3, right? So 1, 2, 3. So now 3 to find the area. 3 times 3 equals what? 9. Therefore 3 squared is equals to what? 9. I don't like this number. So 3 squared equals 9. So square root of what? 9 is equals to what? To 3. So these squares and numbers that we're saying are called perfect squares. So we just keep moving or find more examples, I guess. So we have 4, right? I need to rubber band here, come up here. So 2, 3, 4, right? Is that right? 1, 2, 3, 4. 1, 1, 2, 3, 4. So I need you to have 4. 2, 3, 4. Okay. Okay. So I have now here 4 and 4, right? 4 and 4. So 1, 2, 3, 4. So if I find the area for that, this will become 4 times 4 equals 16. So 4 squared is equals to 16, right? Therefore, square root of 16 is equals to 4. Okay, last we have another one. I hope it will gonna fit. So we have the gray rubber band. So, okay, hopefully this. So 1, 2, 3, 4. I'm not sure if this is gonna fit. So 1, 2, 3, 4, 5. 1, 2. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So it's gonna like overlap on the other side, but you will see now the square, right? So as you can see here, this will become 5 and 5, right? So 5 times 5. So 5 times 5 equals what? Area will be 25. 5 squared is equals to 5. I mean 25, not just 5. So square root of 25 is equals to 5. Okay. So these are the example of perfect squares because you can create a square using those numbers. So 1, 2, 4, 5, 6. So therefore, those numbers that you multiplied by itself are the examples of perfect squares. Okay. So now the question is, what are the non-perfect squares? So we're going to um, see. Okay. You have. Okay, this one. I need a whiteboard, that's why I need to find a new one. So non-perfect square will be, so let's now write down those perfect squares. So we have here perfect squares. Oops, my bad. So we have now here, oops, my bad. I'll do it again. So examples of perfect squares based on our example. So perfect squares will be square root of what? 1 equals what? 1. Square root of 4 equals what? 2. Square root of 9, which is 3. Square root of 16, which is 4. Square root of 25, which is 5. And you can go further. Square root of 36 equals 6. Square root of 49 equals 27. Square root of 64 equals 8. Square root of 81 is equals to 9. Square root of 100 is equals to 10. So these are the examples of perfect squares. So obviously the non-perfect squares are the numbers that will not create a square. So we write down here non-perfect squares. Non-perfect squares. Okay. So if I have square root of 1 here is a perfect square. Therefore, square root of 2 is not perfect square because it will give me this decimal, which is not a whole number. Okay. Square root of 3 is not perfect square. It will give me 1.7. Is that the decimal? It will give me 1.73250, and it's gonna be a long decimals. Square root of 4 is a perfect square. Square root of 5 is not. So 2.23606. So that's another non-perfect square. Square root of 6, a non-perfect square. So that's gonna be 2.44948. Square root of 7, which will be 2.64575. Square root of 8 is 2.8284, and of course square root of 9 is a perfect square. So those numbers that are in between of square root of 1, square root of 4, which is 2 and 3, those are non-perfect squares. So as you can see, non-perfect square, if you put in square root in your calculator, it will give you a decimals. But if you put a perfect square, it's like square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, square root of 49, square root of 81, 100, it will give you a whole number. So it's really a good difference between the perfect square and non-perfect square. So now, from these kind of examples, I know you will use this square root in identifying in real numbers. As you can see here, all the perfect squares will be what? Under rationals, and there could be what? In natural or counting numbers, right? They're in counting numbers. So counting natural numbers. Okay, counting natural numbers. My pen here is not working good. So natural numbers. So therefore, natural numbers, all of the perfect square will be under rational. And so this will be all in rational, right? Because it's counting. So all perfect square will be as counting or natural. It's a whole. It's an integer. It's just a rational numbers. But the non-perfect squares, all of them are in irrational. Okay, I will rewrite this one because I want to write the whole word irrational numbers. Irrational. Okay, irrational numbers, as you can see, is a non-perfect square, and whenever you put it in calculator, it will not give you a nice well-patterned decimals. It has no pattern at all. So all non-perfect squares are irrational numbers, and all the perfect square is a rational number under the counting or natural numbers. I hope that this makes sense to you, because once you understood this concept, you will apply this in real number system, like identifying the best category for each number. So watch out for that. That will be our next lesson. Thank you.